Hello everyone and welcome to our next lesson. This video is dedicated to the discussion on the role of thermodynamics in the energy sector, one of the most important, if not the most important sector in our modern world. In these times, energy is literally power. It represents the power to sustain modern life and the power to further advance technology. In this video, we will take a look at why the study of thermodynamics is important. Let me open with the graph that represents the global energy use from different sources as a function of time. The first thing that strikes you is the exponential increase in global energy use and the diversification of the sources stemming from the first industrial revolution. Another important thing to note is that traditional biomass, such as wood, charcoal, and cellulosic agricultural wastes, has been one of the main sources of energy for the people, and up to now, a sizable percentage still relies on it. The three largest contributors to global energy use today are coal, oil, and gas. They have one thing in common. They all have to undergo combustion for us to convert their chemical potential energy to heat and then subsequently to work. This alone is a compelling reason to understand thermodynamics as an overwhelmingly large part of our energy still comes from combustion. Now let's take a look at the growth in energy consumption of some key regions of the world. The first thing you'll notice is the continuous and drastic increase in the energy consumption of the Asia Pacific region, which should not be a surprise since this region includes some of the most populated countries like China and Japan. Since population size and the development index of countries have a big role on their energy demands, we expect populous and developed countries to consume more energy. That is evident from the consumption of North America and Europe compared to Africa and South and Central America. Based on this graph, we still expect the energy consumption of the Asia Pacific region to grow immensely. There are no signs of it slowing down. If we consider the per capita consumption of energy on different countries, you can see that the Philippines is somewhere along the middle. North America, Australia, the Middle East, and some European countries are all on the top bracket of per capita consumption, while most African nations belong to the lowest bracket. In our country, shown in the graph to your right, we have seen a net increase in the annual per capita consumption of energy from just below 2,000 kilowatt hours per year in 1965 up to greater than 5,000 kilowatt hours per year in 2019. This increase comes from the further urbanization of the islands and concentration of our population in cities. Here is our energy mix for the year 2016 according to the Department of Energy. You can immediately notice the largest parts of the pie, that's oil, coal, geothermal, biomass, and natural gas. Say, for example, that we are using the sources to generate electricity. It would then mean that all of them will be utilizing a turbine generator combination to generate electricity from the heat released from the combustion of the fuel. In the case of geothermal energy, the steam extracted from the ground still goes to a turbine coupled to a generator. If we consider other things that need energy, such as the transportation sector, oil is fractionated to yield useful fuel fractions such as diesel and gasoline, which we then use in the engines of our vehicles. In the engines of our vehicles, the fuel is burned in the cylinders and its expansion provides the work necessary to ultimately make our cars move. From this chart, one thing becomes apparent. Our study of thermodynamics has big implications in our capability to understand, manage, and hopefully improve our energy use in the country. It has far reaching implications, including energy efficiency and sufficiency, and environmental, economic, and social impacts. Here we see that the transportation sector requires the largest energy compared to other sectors. The transportation sector heavily relies on oil and its various fractions such as diesel, gasoline, and kerosene. In this age where even the seas and oceans cannot stop us from traveling overseas and more goods are being distributed globally, we expect that the combustion engines, propulsion engines, and jet turbines are still relevant topics of discussion and can still be subject of continuous improvement and development. This is where our knowledge of thermodynamics can help. We have the knowledge of maximum possible efficiencies and irreversibility that could help us develop more efficient engines. The residential sector is the second biggest consumer of energy, and most of that is in the form of electricity. Most of our electricity is still coming from burning of coal, oil, and gas, which takes us back to the topic that the thermodynamics of the combustion and generation process are still relevant. Even amidst the efforts of the world to slow down the use of fossil fuels, it is highly unlikely that we remove them from our energy mix in the near future. If you take a look at this graph shows the hunger of the world for cheap and widely available oil, coal, and gas. As long as these three sources of energy are kings, our understanding of the thermodynamics of energy generation from combustion will always be useful for technological development, policy making, and overall shaping our future. If you think that thermodynamics is just a simple course that you have to take, think again. In this course, expect that we will study the thermodynamics of extracting work from heat using heat engines, which is the backbone of electricity generation from combustion. This involves the Rankine cycle, as well as vapor cycles like diesel, Otto, and Brighton cycles. The generation of electricity from burning still dominates the global production because it is relatively cheap and readily available. This schematic of the generation of electricity coming from the burning of materials such as fossil fuels will be a recurring topic in our course. We will also study the thermodynamics of transferring heat in reverse of the spontaneous heat transfer using heat pumps. This is more commonly known to us as refrigeration. We will explore the thermodynamics of the vapor compression cycles and liquefaction processes. Looking forward, thermodynamics still play a big role on the development of alternative sources of energy. Shown here are the most heavily invested renewable energy sources, indicating that solar and wind energy could be our future. This still operate under the limits of the laws of thermodynamics. Count that as another incentive to understand and strive in the study of thermodynamics. That's it for this lesson. I hope you've learned something. Thank you for listening, and as always, keep safe.